Hello, everyone. I'm going to start by introducing ourselves. Randy Smith.
I'm Ken Allen, Associate Director of the Watershed Committee.
Cliff Bradley with Montana BioAgriculture, talking to you about mushrooms and mine waste and actually fungi and mine waste.
Egan, Jankowski-Bradley from Montana BioAgriculture in the talk as well.
I've done the Port Programs Manager for the Elkhorn Watershed Committee.
Diane, have you wisdom?
I've been thinking weeks of water utility. Matt Norwood, Montana BioAgriculture hydrologist. Mike Geary, outfitter guide. I'm Sean Lewis with the NRCS. How's it going? Sean Clacker, the Media Conservancy. How's it going? Paul Clary, president of Land. Jim Hagenmark, the ranchers in the Land. Hi everyone, I'm Sonny Colborough with the Forest Service in Butte. I'm a cleanup project manager. Working with these guys on Elkhorn Mine. Corey Morris, Future Tom overview.
Wendy Bowler, you?
Harley Riley was Bennett.
Cool. Hey, since Pedro's not here, I got stuck. So bear with me. Matt, I think you're next.
You want me to stop sharing this, Tara? Here, I'll stop sharing so you can pull it up.
Everyone see that okay? I'm blind.
It's about the best I get.
Oh, thank you. Hi, everyone. Sorry, it's been a while since I've been here. The last meeting that you guys had was in June, and I was over on the Yellowstone, documenting those flood conditions. That's pretty crazy. I mean, talk about quite an event. But anyways, here we are. It's August, the big hole. You guys all look out your windows and drive along the river and see what's going on. Stream flows in the big hole below to well below average for this time of year. Been hot, dry, windy at times. So that really does not help stream flow conditions. So we're getting near those base flow conditions probably earlier than the median values. With those lower stream flows and hot, dry conditions, we get elevated temperatures in the river, and we get a lot of biological activity, such as algae, different things like that. So we've got some fishing closures on the river. We've got hoot owl restrictions on sections 2 and sections 4, and full fishing closure on section 1. And then today they just issued the closure for section 5. So here's just this is as of this morning, just the flows from USGS gauges. And then here's the NRC gauges that we operate in the upper big hole. The lowest ones at Dickey Bridge. And I just put this in there for the notes. So if you scroll down, it's just hydrographs of all the different sites. You can see Wisdom is down below 20. And then keep going down. And we're just low. It's just that time of year, it's just hot and dry. We've got a couple storms lately, but June or July, and then to the beginning part of August, it's just hot and dry. I mean, we're well above our average temperatures and below our normal precip, for these last couple of weeks. Yeah, just those triangles here. These are all our median values right here, so you can just see that we're low. Where we should be this time here. One more graph. Okay, precipitation. The good news is that we're right on track with precip for this year. We're 99% currently and 92% for the total water year. Water year ends September 30th, so we've got about 44 days remaining. You know, if you look at the graph, this is the black lines this year. This was last year, so we put here. If you relive nightmares from last year, shows that we're doing considerably better in 22 than we did last year in terms of total precipitation. Again, you know, with the exception of some some storms lately, you know, July to the beginning of August was dry, and this directly correlates to these declining stream flows. I just want to, you know, remind everyone, you guys all know this, but you know, even though we're at 99-100% basically of where we should be, it's all about timing and intensity of these precipitation events, right? So we might be running on the average line, but what happens sometimes, like this year's a good example, you know, we were in deficit coming up into runoff. All of a sudden it got cold, got a bunch of storms, which is great. Boost our snowpack. June it was cold, rainy, and then the tap shut off. So it elevates that line, which is great. But wouldn't it be better if we could just keep some steady storms going through the season? I mean, that's what, you know, that's what keeps soil saturated. That's what keeps, you know, ag lands going, forest lands, stream flows elevated, things like that. It's kind of, you know, we're looking at that trend, you know, climatic trend moving forward. You know, we get these, we might be looking at, you know, the same precip on a yearly basis, but it comes in these high intensity events, right? So you get these periods of rain or big shots of rain and then nothing. That's pretty hard to sustain. Right? Go ahead, slow down. So drought status, significantly different than last year. For, you know, much of the upper Big Hole, they're calling it, this was reported as of last month. So things are probably going to change. I think their timing is just a little off when they come out with the reports, but we're looking at, you know, in the upper Big Hole right now, when this came out, zero drought, which is a significant change from last year. I'm thinking it's probably going to go to a D1 coming up. And then the rest of the basin here, move down, you know, we're looking at normally dry conditions. And again, I don't know if this necessarily correlates with the hot, dry conditions that we've had over the past month. So go ahead and move down. Okay, so our outlook, our 8 to 14, our next couple of weeks, kind of the same thing, hot and dry. Above average temperatures, below average precip. You know, the dog days of summer are here. Hopefully we get a couple of localized thunderstorms or maybe a regional storm to move in and cool things down and, you know, maybe soak up some soil around here. But Southwest Montana in general is looking, you know, pretty much the same as we've seen over the past, you know, month or so. Go ahead. Our seasonal outlook. So, you know, from this point moving forward into the fall, into the early winter, not super awesome either. Hot and warmer and drier. I shouldn't say hot. Warmer and drier. So hopefully we can, that trend will buck a little bit and we'll be able to get some rainstorms in the fall and we'll be able to recover some of that soil moisture. Okay, move down. This is kind of interesting, so keep going a little bit more. Okay, so right now we are still in what's considered a La Nina event. That means we have sea surface temperatures that are below, or they're 0.5 degrees Celsius below the normal. And we're expected to continue. Chances with La Nina gradually decreasing, going basically into the winter time. So this is kind of an interesting thing because this is unprecedented. This is the third year in a row that we'll be going into La Nina into the winter. That's only happened one other time in the 73-year period of record. So what does that tell us? It doesn't really tell us anything. I mean, we don't really know. We don't have data to support what that means. What does it mean for the Big Hole? Again, we don't know. Typically, we've seen over the past, La Nina conditions typically tend to be wetter and cooler for Montana. It differs around the country. Montana, we get cooler and wetter conditions. However, with the exception of this last spring, these last 2 years, we had La Nina conditions and people were optimistic, oh, we're gonna get back to some good water. Well, it hasn't really panned out. I mean, if you look at going into 2021, that winter was dry and warm. Same kind of thing this year. I mean, we got real lucky towards the end in April and May, and that's what really helped us push us through this year. But so we don't really know. Does this mean that a La Nina trend is changing or kind of changing in Montana? We'll find out. I guess if you get 3 years in a row with something like that, it could be interesting. It's really too early to start making predictions for our upcoming winter and our snowpack, things like that. So let's just kind of see how it goes. But again, I mentioned this earlier, the general climatic trend is showing warmer and drier conditions. And this is like globally, not just Montana, but, and we talked about these shorter, more intense storms. So I would be ready again, and I hate to be Debbie Downer, but I would be ready for some shortage. The last couple seasons we've had shortages, especially in late summer, like we are right now. So hopefully we can buck that trend and La Nina will actually show her face and like really produce. But as of right now, I guess we'll wait and see.
The last time we saw it. 2017.
I'd have to look. I know 11 for sure. That was
Yeah, that was a lot.
Number 17 we did not. Any other questions? Oh, yeah.
Matt, where's the Lynn gauge?
I'll refer to someone else. I don't actually know that.
No, it did not.
Yeah, but not where,
The notch one.
perhaps.
I think it's public. It's on, okay. So isn't it on Rapids Bridge?
The reason I haven't, deviated quite a bit. What are they adjusting or what are they doing?
Big drop.
From 10,000 to 70.
It's certainly so years.
Yeah.
Okay. Gotta wait. Let me get that set up here, yeah.
I think that is the backdrop, we should be able to fancy.
Yeah. That's right. No, I'm gonna see if we can get Pedro. Pedro's in Brazil still, guys, so. Whoa. Turn it up a little bit, test.
what water management in scarcity can look like, can feel like. How,
behind you. All right. Very cool. There's a lot in there. I really encourage folks to sign up for that text drought number too. It's really handy. Has anyone signed up for it out of curiosity? It's really handy. Dan's doing a really good job on it. And it's a very simple, basic rundown of where we're at. The triggers, flows, etc. So I'm getting a text and I like it. So I encourage you guys to do it as well. Jim you're signed up. Cool. Awesome. Check down further down. Then take a look at those maps. Seriously, they're really sweet. A lot of thought and effort was put into those. We're excited about it. All right.
So Pedro mentioned FWP looking at the Murphy rights. And I talked to the guy up at, I can't remember what his name is. And I tried to explain to him that a lot of those rights that are late filed are probably, there's nothing there. And I know some in particular that are on our place that used to belong to Hagenbars up on McCartney Mountain, if anybody's ever been there. And there's never been water that's made it to the Big Hole River in the 40 years that we've owned it. So, except one time there was a flash flood. Nobody was stopping it. So anyway, I think a lot of those are like that. So what I suggested to FWP was that we need to sit down and look at how many of those water rights are really viable to deliver something to the river. Because I don't know, there's some that are for in-stream flow for fish ponds, but you know, they're just running through, so I don't think it's gonna add any more water. But anyway. Who wants to do the steering committee report? Roy or Jim?
I am half on.
That was a long time ago. Everything's going well. How's that?
We had a meeting. Covered an awful lot of issues. This committee is very, very active. And we're dependent on 3 very capable individuals to run it for us. And we have to be very careful that we don't burn them out. And make sure they get paid enough. But sometimes your wage, you know, leisure time is paramount if you have a family. All 3 of them have families with little kids. So we got to be careful not to overload them or let themselves overload themselves. We talked about that a lot, and a lot of exciting things that we could do down the road. But we got to make sure what we're doing right now is we continue to do an excellent job. So that's about the gist of the whole meeting.
Yeah.
All right, I'll just do a quick wildlife update. I don't have that much to talk about this time around. But our range rider program is in full swing, so it starts July 1st and goes through September 30th. And our range rider, Chet Robertson, monitors 6 U.S. Forest Service grazing allotments for 7 livestock producers in Upper Big Hole. And he looks for predator activity, livestock conditions, and helps identify injured or dead livestock in the hopes that livestock producers can get reimbursed for their losses from wildlife services. This year, the program is funded by the Livestock Loss Board and the NRCS through the Western Landowners Alliance and the Heart of the Rockies initiative. And a couple interesting developments this summer. Chet found the remains of a wolf. So that has never happened before, but there wasn't much left. It's in that picture on the top right. You couldn't quite tell what happened to it. He's ID'd 2 injured livestock and 1 carcass, but so far none of them were eligible for reimbursement. You just couldn't tell what had caused the damage. And multiple wolves been photographed by our game cameras this summer, and Chet has found lots of tracks. And he's also photographed black bears and found grizzly bear tracks in a few different locations. So Big Hole. So lots of activity out there, but thankfully, well, not a lot of depredations this year that we heard about anyway. That's all I've got for wildlife.
We had a successful wildlife speaker series.
Oh, yeah. Yeah, and we did have a wildlife speaker series event on July 14th. We talked about beavers. We had about 25 people show up, and burgers donated by Jim Egan here, and Andy Soderham donated for the drinks and all the other stuff that was on meat. And we had a really good time, and we got it right here in the range. So thank you to everybody who came to that and donated.
Yeah.
Okay.
Thank you.
Yep. Get my presentation up here. I want to do that. All right. All right, guys, I've been a busy bee since the last time we all met. I'll go run through some of the projects that I've been working on since June. I'll start off on our Upper Oregon Creek project. And we had a really productive couple of months here on Upper Oregon Creek. We had a 2-week hitch in June where we built 99 in-stream structures, both beaver dam analogs and post-assisted log structures. I don't know why that just happened, but we had watershed court consulting out there, an MCC crew. We had a Wild Rockies Field Institute class come up. There's 26 students who came up and built these BDAs with us. And actually I had a Wisconsin church group come drive all the way out from Wisconsin. It was actually my wife's dad and his whole church group came out, and I got some volunteering hours for them and some good match. But they were just ecstatic about it. And we had some really good teamwork building those. And you can see these are just some of the photos that we took. I took copious amounts of photos, but that's nothing new. This month, we've already had 2 full weeks of goalie check dam installation. So we did the in-stream work capturing that sediment in-stream, and now we're moving into the uplands to capture all of that erosive sediment coming out of these goalie networks. A couple of really great photos from that I'll show you here in a second. Up next for Upper Oregon Creek, after we get the rest of these goalie check dams installed, I have another MCC crew coming out, and we're going to just be revegetating those uplands, those erosive hillsides. So we'll really capture, the in-stream, the goalie capture, and now getting all that vegetation established on the hillside. And with that, I'm also going to have Heli Works out of Deer Lodge do all the helicopter seeding and fertilization, about 25 acres of that. So that project's really coming along. I'm very happy about progress we're making on it. These are these goalie check dam structures that I'm speaking of, and I took some photos just for scale. There's this crew member here, Alex, on the lower portion of your screen here. He's about chest height at the top of one of these goalie check dams. So we're really building them stout, and there's some pretty big goalies in this area. And so I'm happy with the crew that I have this hitch, because they're going kind of above and beyond what I'm asking them to do, and they're having a blast with it. So that's Upper Oregon Creek. Our Upper French Goldfish Passage project started this last month. I've been working on this one for about 2.5 years now to get it implemented, and we broke ground. Again, I have another watershed consulting crew. They actually won the bid on this one. So I have guys working in Upper Oregon Creek and French Gulch right now. So I'm kind of bouncing back and forth on oversight. But this far left photo here is from this afternoon, right before I came to our meeting. They're building the first step pool out of 26 up here. So they're building these things with 4 to 6 foot boulders. It's a very big effort here, a lot of earth moving, and they're going to have to gain about 40 feet of elevation every step of the way, if you will. Boom, there's a joke. So I got Upper French Gulch moving and grooving. That'll take another probably 4 or 5 weeks to finish that one up. Elkhorn Mine and Mill, I'm going to let the pros speak on that. We have 2 great presenters going to talk to us about all the mycelium biofiltration studies that we have them contracted to do for us. And then also the other great headway that we've made over the last time we met were Pioneer Technical, who we've contracted out to do the soils characterization work up there. They did their field work portion. They sent all of the soils to the lab to Minneapolis, I believe, this lab called PACE. So they are waiting for their data. They're going to write a big characterization report, help us with the beginnings of a conceptual design to get those soils off of the landscape. So we've been working on getting this soils characterization done for a little bit now, and they did the kind of the heavy lifting, if you will. This is the gal who's at the 300-foot level at it, working with Pioneer, getting some samples, throwing them in a bag, and pretty picturesque little office she had for the day. Again, I'll let Cliff and Egan talk about this mycelium pilot biofiltration project that we're doing up there. And another really cool thing that came out of the last couple of months was Montana Tech. They did some additional drone flights into the added portal. We did a flight last year and they flew about 100 feet into the added portal. And then this year they came back and I think they got about 300 feet in. They did about 7 flights. And they're really, it's really neat. And maybe perhaps during the break, I'll show you guys some of those while we have some coffee and snacks. But a lot's happening at the Elkhorn. I'm very pleased with the progress we're making up there. Other happenings in my program, Pedro and I finished the 2022 performance monitoring for the NRD that we essentially have to do for EPA. We're getting so close on final sign off with EPA on the Anaconda Uplands restoration and remedy that we've been doing. Boy, over the last 10 years now. And we did a monitoring report for them in 2021. And now we just finished up the field work and the report writing for that here for 2022. So that's now in NRDP's hands. I might get one more draft back, but that was quite a bit of work on my end to get that completed. Pedro mentioned the Wise River monitoring, doing about 1 month, every month or so, we're doing these flow measurements in the Wise River. So that has been an effort, but it's been fun to be out with Pedro. That's him in the middle of the creek there. Project planning never ends for me, which is a good thing, but I'm making a lot of good headway on the Smith Sage Springs restoration project. We have sort of our funding is complete, we're ready to go. Permits are pretty much submitted into all the permitting agencies. I think we have our fence contractor ready to go. He's signed up. I think we're just waiting for when his schedule can open up for that. Hopefully we can, if the stars align, we can get that project completed this fall. Pretty hopeful for that. And thanks for Jarrett and company for getting the wetlands delineation done for us. That was a big push for our permitting. So other projects plannings is the Eastern Pioneers. I have it, it's BDA right now, but it's really in-stream structures. I've chatted about this one with you guys before, but it's 3 different stream reaches in the Eastern Pioneers that we're doing low-tech work, these beaver dam analogs and post-assisted log structures, and working with Sean Claffey on that project as well. So I'm actually going to have the youth employment program out of Dillon start on those in a couple weeks. And so excited to get those finally installed and on the landscape. And then lastly, I've been prepping for a American Fisheries Society talk that I'm giving next week in Spokane. It's actually for the Lower French Creek project that we implemented in 2019. We won they call it the Western Division's American Fisheries Riparian Challenge Award. Mouthful, but we won that award in 2020, and they wanted me to come speak about that project. And so I'm going to Spokane next week and going to go speak at that conference, and getting that talk and prepped is taking some time out of my day, and but I'm looking forward to it. So I think it's a good opportunity for the Big Hole watershed to get some good press and to get the good work that we're doing out into the public eye. So that's all I have. Thanks. Any questions? Jim?
Do you have much trouble with leasing? Or do you have your
For which project, Jim? Let's see here. So NEPA is really with my understanding is with the federal lands, and so for Elkhorn we're sort of covered over CERCLA, so we don't have to really worry about NEPA. And then the fish passage projects on state land, and we got NEPA done for that one. And then the BLM stuff that we're doing in the Eastern Pioneers is sort of all that compliance is done on that federal level as well. Actually, yeah, it's under the programmatic EA. Thank you, Sean. Yep. So, yeah, we're sort of following in line with all that, being compliant with everything. Agencies.
Thank you, man. All right, one more little order of business. We're hopefully going to well. Remember. So. So anyway, any opposition to welcoming Sean Claffey on board?
I think it's just making room for room.
Oh.
We'll talk about it.
Yes. Do we have? Do we have?
Observation, just.
Okay. Do you want, maybe you want him to give us a peek? You want to talk a little bit about yourself?
Yeah, I guess. I introduced myself with the nature conservancy. You guys had on the agenda here, and then we work with the nature conservancy, but what I do is I manage or coordinate the Southwest Montana Sagebrush Partnership, which is really like a big watershed community part of it. So through the Sagebrush Partnership, which we, I guess, really, I've been around for a long time, but kind of formally came together in 2018 when my position was created. We focus on increasing the pace and scale of sagebrush set conservation, and what we're doing is moving conifer expansion. Cheatgrass, we're haven't really made a lot of progress, but we're developing a strategy and starting to make moves on what we're going to do about cheatgrass, riparian and wet meadow degradation as part of, I mentioned that Eastern Pioneers project. And then wildlife movement, or improving wildlife movement across the landscape. So I guess in the last 4 years, the conifer expansion has really taken up a lot of my time. We've made some good headway there. We've also been working a lot with a lot of those that work. Drainages and start moving the drainages across the Grand County as well. Yeah, I'll leave it at that for now. Wanted to be here, thank you. Morning.
Sometimes not real well. Huh? All right. Anybody got a problem? Okay, welcome. All right, we get to take a little break and then Ben will. So there's some cookies up here and coffee.
And you can also get water in the kitchen, don't be shy.
acidic water, there are positively charged ions, so lead or zinc or copper or whatever, all carry a positive charge. And there's a lot of biological materials that can carry a negative charge, so the metals just stick. And that's the fancy term for that is biosorption, where the metal ions absorb to some kind of biological material. And this over university researchers have been working on this kind of stuff for decades, and they're testing everything from seaweed to activated carbon. Activated carbon is a little too expensive. Montana's kind of far from the nearest ocean, so we don't have much seaweed. But one of the really life forms that have worked really well in absorbing metals out of hazard mine water have been fungi. And there's been a lot of academic research, university research on the fungi as how they absorb toxic waste or how they remove metals from water. So research has covered what mechanisms are involved, different metals, water conditions, all kinds of variables that have been addressed in the lab. There we go. Fungi are not all created equal, so there's been a lot of different species of fungi tested for this. The one that's consistently worked the best, and the one we work with, are fungus in the genus Rhizopus. That doesn't mean much to people, but they're very common soil fungi worldwide. They're non-pathogenic. In fact, in Asia, Rhizopus is used to ferment soybeans into tempeh. If everybody's had tempeh instead of steak, you'll know what I'm talking about. There's a lot of industrial uses for these. And the project we're only using isolates that are domestic for the US. There's no importing of exotic organisms here. And the other thing is, the title of this, or one of the things talked about, mushrooms. We're not really working with the mushroom form of the fungus. We work with what's called the mycelium, which are these threads, cells of the fungus that form this web of cell interconnected cells that are called mycelia. And that's the form of the fungus that actually absorbs the metal. So that's what we're working with. And we have some petri dishes here that we can pass around to show you what Rhizopus actually looks like in culture.
They're a little bit old, so they're not like as fuzzy and good looking as the photos, but
And it was kind of hot in the car coming over, so. Okay, there we go. A little bit more, okay, that better? Okay, so sorry, I got in the way here. The way this actually works, the mechanism is referred to as ion exchange. The cell wall structure, the outside surface of the Rhizopus, have very strong negative charge, more so than most other fungi and most other biological materials. So the positively charged metals just stick to the cell walls. The fungus doesn't have to be alive. There's a lot of biology and remediation using live organisms. In this case, we grow up the fungus, but it doesn't have to be alive. The cells can be dead and still store metals. There's been a lot of work, a lot of research in the mechanism, real fine research in the mechanisms, and we won't go into a lot of that detail of how the rates of absorption, different metals, using pure cultures. Almost all of this has been in laboratories where they're using small culture flasks and pure cultures of the fungus in sterile conditions where they have the water is known concentration of one single metal, the pH is controlled, et cetera, to work out the mechanisms, which is fair enough, but needs to be translated to the real world. Fungi that can absorb as much as 30% of the weight of the dry weight of the fungus body in metals to the outside of the cell. So there's been a lot of proposed systems, very fancy systems of fluidized beds pumping water through one end and collecting the metals. And then a lot of these, because it's really expensive to use pure cultures of cells, they want to incorporate a step where they remove the metals again in a higher concentrated form. So there's been a lot of sort of paper studies and proposals, but as far as we know, there's been no really full-scale implementation of this technology, certainly at the scale that we're looking at Elkhorn. So some of the issues we're trying to deal with here are to get from the really good laboratory work to actual practical field implementation. As I said, you know, they're using cells grown in a couple 100 ml shake flask. We have a lot of these in the lab and we work with them, but if you're going to deal with a real world site, you don't need grams of cells, you need tons. So how do you produce that? And you need a practical treatment system. Using a pure culture in the lab isn't it. And you also have to work with real world contaminated water. I mean, the water coming out of the added Elkhorn has a whole bunch of different metals in it. The pH is whatever it is when it comes out. We don't get to change the pH or adjust anything. You need a system that's scalable to a pretty large scale. It has to be low cost. And you also have to deal with what you do with it after you collect all the metals. Can you dispose of it or versus recycle it? And how do you actually measure performance in a real world system in the field? Basically, there's been a lot of fancy laboratory studies, but basically it comes down to how much volume of water could you treat for one unit of culture, fungus culture, how much water will one unit treat and over what time period. So that's some of the things that we've been working on to scale up for the Elkhorn site. And with that, I think I'll turn this over to my colleague Egan, and he's done a lot of the heavy lifting here, and he'll can explain to you more about what we're actually doing.
Hello, I'm Egan, and I'm a Montana BioAg's lab and field manager, and taking it from like Cliff's talking, we're scaling up in the lab. And so what I designed and to implement and first try in the laboratory to see how to scale it up is fungal bioabsorption columns. So like you saw the previous picture where they're talking about a fluidized bed, which is a little different. And what we're working on is more of a packed bead column type system. But our recipe for all this, once it's done and formed, is like Cliff is saying, it has to be low cost. We have to be able to dispose of it and scale it up. And so our recipe to do all that in an efficient manner is we have corn cob fractions. So the woody interior pulp of the corn cob, which is normally used as they blast the side of log cabins to remove finishes or dry baseball fields as part of it or do whatever. It absorbs water really well and is good, but it's a waste product. So it's cheap and there's a lot of it. You can buy it rail cars at a time. And then just barley flour as a fungal food source. And that's pretty cheap and easy to get. And when we're growing it for the whole, when we're talking about kilos of substrate, the barley flour is only 5 to 10% of it all. It's not working at eating a lot or doing or growing. I mean, it grows very quickly, eats all that and creates a whole bunch of cells. And then there's just a little water and the rhizopus biomass, which we start off with as a spore. So growing and test screening, we started off with some beakers because there's, like as Cliff was saying, there's all these different rhizopus cultures out there. So there's a whole slew of different species in the literature. They were talking about, everybody has their own rhizopus that they try to use and try to screen. And I think we ended up with 10 domestic isolates and have narrowed it down to about 3 or 4 that are working the best. So we grow it in bags until it creates a whole bunch of spores. And on average depending on what fungus we use, but on average we get 2 times 10 to the 9th spores per gram. And that's with some biomass in there, the barley that's grown on. That's actually a pretty low number for what we grow in spores. And then you can see there's the corn cob woody fractions, and it grows so well and binds it that I can pick this up in a whole chunk in my hand and it won't fall apart. And then these small beakers, we were just dribbling water into the bottom and percolating up through to simulate our future column.
One of these buttons.
That's space bar.
This one?
Space bar.
Oh, the space, oh, there we go, okay.
So
There we go.
the first step was beakers, and then I decided how were we going to do this and implement it at the Elkhorn Mine, and the best thought and was columns. And so I designed columns first in the laboratory. These are just PVC pipe that are 3 inches wide and 2 feet long. And I grow the rhizopus culture with that recipe that's pretty simple, and just pack it in there and allow airflow to go in. And 5 days later, the tube is packed with spores. And then I run the acid mine drainage through it. And so working on optimizing the system. So this is more what I'm talking about for doing a packed bead column. So you have larger or small particles, and we determined that a little mix of both on some woody corn bits would work the best. And this was just from a paper that we had. So the arrow should be the other way, because we're actually percolating the water through the bottom. And so you don't, it would tend to channelize. If you put stuff to the top, it would find the path of least resistance. But if you push it in from the bottom, it contacts every cell through the whole system. And so trying to figure out the mass transfer zone or pressures to do it, it's the system doesn't require any long game time or anything else. As soon as the water reaches a little saturation point inside the column, then it immediately binds to the fungus. This is fun, really busy slide. But just kind of breaking down what I was talking through first, you can reach a saturation point. So the column has to get wet, and the corn cob is an absorbent, so it does absorb some on its own, and the fungus. And so once you reach that first saturation point, then you start grabbing the metals. And then you have a certain amount of service time until what we call as a breakthrough. And so you start seeing those metals again on the outside after they have been absorbed. And so we're working on this from taking it from the lab to doing all this on a larger scale into the field. So how we do this and understand what's going on, we do laboratory assays, and we've also sent samples away to energy labs in Helena. That's where Big Hole Watershed brings a lot of their water samples. And so we started off with test strips. These are testings for zinc. Here's a high level of zinc. There's the added water. You can't really see this in pictures. I thought it would come out better. And then the zinc disappears through the color scale. This is another one that's a little easier to see. So when I'm talking about saturation, so this measures a scale of parts per million. So if there's a whole bunch of contamination, it's down here. So this was waiting for breakthrough. So it starts grabbing some, but then there's this quick drop, and then the parts per million get super clean. So this is 30 parts per million, and that is less than 2. And that is for determining water hardness, which is a combination of calcium and magnesium. We have now taken those tests that are a little more rudimentary on test strips and do whatever else, and we have found this good company, ChemMatrix, who has a lot of the tests for spectrophotometer, which we run through an absorption spectrum, and we get a better, more exact number. And so we always, every time we run samples, we run a baseline of what's in it, and then we can take samples. We don't, yeah, those are too hard to see. I mean, I just don't think anybody else can really read it.
No,
so.
I don't.
So this is just what's in it. The Elkhorn Mine, if people don't know, has arsenic, calcium, copper, lead, magnesium, manganese, silver, and zinc. Some in all different parts per million. Some are worse than others, like the calcium and magnesium add up to 33 parts per million. And then things like zinc or 2 or manganese or things. So some of it's not extremely high levels of contamination, but what I'm talking about is the volume going through. So this builds up over time, and it's worse for aquatic insects and then the fish. So a lot of these wouldn't come up on like the EPA's thing for your daily consumption. You could drink some of these and you would be fine. But overall, for the aquatic systems where the insects eat it and the bugs, and they eat each other, and then the trophic levels cascade up where the fish then eat all the insects and it builds up in them. And so this is the lab column that I did, one of our tests. So this you can't see is volume, and it's at the end after a certain, I think we did 21 hours, we did at a slow pumping rate, we did 52 liters for 2 kilos. So And on average, every 1 kilogram of biomass with fungus and corn cobs, we do 25 times the amount of water and can fully clean that. And the first thing that starts breaking through over time and getting higher is the water hardness, the calcium. After 52 hours, we're still less than half a parts per million of zinc, and we're starting out at 2. So even when you start breaking through with certain minerals and metals, there is more to go. So that's why I've designed a modular system. So the calcium and the clay and the large particles will start clogging the system and making it not absorbing as well, but we're still grabbing other sort of metals. And so you keep that column in place, it can still grab metals, but then you have a column after it that will continue to grab the calcium or other such things. We've all just seen lots of pictures of the Elkhorn Mine at it, and then the stream coming out of it. Correct me, that Ben, what, like 20 years ago or 15 years ago, they channelized, they built a whole big channel, and that has filled in with sediment and minerals and metals. And so this was a big channelized stream, and now it's just all sediment and other interesting microorganisms growing. So here's the switch from the lab scale where it's a couple feet in a small pipe. These are as tall as I am. They're 6 feet tall and 6 inches wide. And so I've got a nice full column. You can see all the pure amount of cell mass that grows in between the void spaces of the corn cobs. And it comes out as one big chunk if I can get it out of the pipe nice. And so these are going to be designed, we haven't, to be placed at the Elkhorn Mine and growing. We are planning on implementing them next week. So we'll dig a waste basin or I guess not a waste basin, just a basin, diversion basin of 60 gallons that I will pump out of, and then just downhill and pump them up through the columns. So it'll start at the bottom, go up through one column and go to the next through the series of the 4. And we'll have between columns be able to take the water out and test it to see when breakthrough is happening each pipe. We have a spectrophotometer we're bringing in the woods with us, as well as all the different chemical tests. We are manganese and zinc with the levels that are in there are sensitive enough through the spectrophotometer that we can see those break through. The water hardness one with that funny little pink thing are not as accurate and don't show an accurate picture of the breakthrough, but they're still a handy tool. So we're using those as well. Oh, yeah.
With your pilot study, how many times did it take for you guys to filter that acid mine drainage through to get sort of clean water for your particular metal?
Well, like we haven't yet done it out at the site, but in the lab scale thing, it was until we start seeing the hardness, the calcium, the magnesium, we've done 25 times the amount of biomass. And so each one of these, the larger pipes that are going in there, has 30 pounds of biomass inside of it, or go back and forth between metric and regular too many times, and so I've lost track. So that's
15 kilos, give or take.
Yeah, so give or take 15 kilos, and so we should be able to do 25 times that amount of liters per column, and that is just getting through the calcium and magnesium starting to break through. We're still doing cleaning up zinc, still cleaning up some other things. Some of the problem is this site we've only been at a couple times and trying to get the acid mine water and to understand how much the concentrations change with the breakthrough points for the different various metals. And so we've only been able to bring back 25 gallons at a time from the Elkhorn site. And so that's why we've kind of maxed out on, we haven't gone all the way through breakthrough even for our lab scale. So yeah, there's only so much you can do in the lab for something like this. So, I mean, I'd love to be able to bring 200 gallons and be able to do that in the lab, but it's not possible. We've created our own synthetic metal mixture. So we took all sorts of different lab metal chemicals and created 1,000 times concentration. And so I could dilute from that. And so we could have faux Elkhorn acid mine drainage based off things from last August. With that we had an energy lab sample from. So, and then even in the lab scale, we have, so we could see it through the spectrophotometer a little easier. We, 10 times the amount of copper. So we could see that metal breakthrough more accurately. And so we were at that point with synthetic acid mine drainage that we did in the lab, we did well over 30 times on a filtration basis of per body mass before the copper started coming through at 10 times the amount of copper. So the system is harder to nail down with all these different metals in it. And so this is why we just need to get up there and run stuff through and in a larger volume. So, and so this is where we're talking about our work plan. So we're just gonna go up to the adit hopefully next week, and then in a couple weeks from now, do a larger demonstration with Ben and Pedro coming out, and Sonny or anybody else who's interested from the Forest Service or Bureau of Mines or something like that to see it in action. I think we were talking about the second week of September for that. So we're going to nail that down, and Ben and Pedro will coordinate and put that out to whoever wants to come up and see it. And then we're going to, after that, compile the data and confirm results with energy labs, and then continue to work and on this grant and finalize it. But this was a small grant through Beaverhead County and the Big Hole Watershed Committee and contracting us to do this work. And so we want to continue to go after, there's another grant cycle coming for, this is all based on a $50,000 grant. And so hopefully we can work and get another one of those with some good data and continue to do this to sort of work on fungal growth parameters so we can maximize how I'm growing fungus in the lab, or how we would upscale it even much larger than the pipe system that I have. So this is just a small pilot system. We work with people that everybody at the powers that be. I mean, the Elkhorn Mine is a major undertaking. It's 150 gallons a minute coming out of that. It's a lot of water with a small amount of toxicity, but there's also large waste rock piles. There's different sites. The mill site has even other hot spots in there and things and seeps. And so figuring out how we fit in on the Elkhorn Mine site, my vision is at some point, the large waste rock pile that's right underneath the adit will need to be moved and get away from water infiltration. And other major work and a lot of earth moving would probably happen on site. And so we'd like to be downstream of that and help, like there was a lot of restoration work on Elkhorn Creek already. They rechannelized it, they dug up stuff. There's been a ton worked on and cleaning up and the restoring a thing. And so when everybody digs everything up and instead of a large pulse of metals and mess and contaminants going down in the creek and ending up in the Wise River and the Big Hole, we would like to implement this, and it's going to be in like a trench system, potentially some sort of zigzag thing. So we would catch those big intense pulses of metals and sediment and other sort of things as part of this. We're a tool in the toolbox for this site. What I really love is there's acid mine drainage sites all over the state, up in the Pioneers. There's plenty other ones that seep a lot smaller volume of water seasonally or with higher levels of contaminant, but not as much water and other sort of things, where this system would probably be more ideal. But we view this as a great opportunity to try this technology out. And with DEQ and other people, in other agencies, you have to be a past proven technology before they allow you to clean up toxic waste. But it's really hard to find your own toxic waste site to say, hey, this has been done in literature, let's do it on a large scale, let's prove this, let's have a past proven technology. And so this is giving us a good opportunity to prove this on a larger scale. Oh yeah, this is just talking about more of the Elkhorn Mill site. There's different springs that was coming down along the side that have much higher levels of contamination. There's like zinc levels were 20 parts per million or something in one site, Cliff.
Yeah.
Out of these little seeps that are happening on the mill area. So even if this adit is worked on and dealt with, there's so much such a large site and so many issues and so many problems that we could piece our project and our rhizopus cultures in different places on the landscape. Yeah. And we're open for lots of questions. We know it's a different sort of biology than you guys are used to in some of the restoration practices, being some weird fungal microbiology stuff here. So probably the volume of water. I mean, it is a lot of water, and the contaminants aren't that high. So that's what I was talking a lot. There's, I don't know, 10 to 100,000 mine sites in Montana that have acid mine drainage water seeping out of them. And some of them have a lot higher contaminations and lower flows where we could deal with that whole site every year. But Elkhorn has so much water and is going to be running at such a high rate forever that this might not be the final be-all solution. But like I'm talking, it'll be a good tool in the toolbox if we need, can act like a filter. And so save a lot of the work that's already been done on restoration of the creek. And so.
But one point of those drone flights into the mine shaft there were to explore if there's ways to reduce the water flow out of there, or divert it before it gets contaminated. And, you know, so there's multiple solutions and to different ones. Or as Egan pointed out, that some of the drainage from around the mill site is very small volume with very high concentration. Some of that actually in total metals into the creek is probably worse than the adit, but there are volumes that we could probably deal with much more efficiently. So there's ways to incorporate this, and we want to figure out how to work with people to do that.
And another reason why we would use corn cobs and the rhizopus is we're not trying to create another mess. So a lot of remediation or restoration work is digging up a site and transporting it somewhere that you can keep it away from water. And so, and then just, or volumes, or like cleaning up the Berkeley pit, for example. Every time they do, they get this intense sludge, and then you have this large volume of contaminated stuff that you have to figure out what to do with. Well, the idea with using corn cobs and these rhizopus is you could get a low heat ash, and so you could burn off all the carbon and be left with just the metals and a little teeny bit of carbon left at the bottom. So you would go from a larger mess of metals and the site to a small concentrated thing. And if the concentrations of metals are high enough in gold and silver, you could recover them. So, and this is a problem all over our landscape, as everybody, most know. It's some of the basic biology of mines and geology is anytime you oxygenate the sulfur-loving ore bodies, there is sulfuric producing bacteria. And as soon as there's oxygen in water, they're going to create sulfuric acid, drop the pH, and metals are going to be in solution. Every time some guy in 1900 dug a hole deep enough, they created acid mine drainage. So there's no shortage of these problems. Yeah.
Question. You were saying that through your cylinder or your clarifier, you push the water up.
Mm-hmm.
And do you have any way, do you measure your pressure or head going through the biomass at all to determine filter run time or anything like that?
Yeah, we're working on that. So it's how much the rate of flow is. We're working on that. We don't have a great measure in those columns. We just measure how much with the pump. I have a brand new pump that I haven't tried yet, so I have to work on the flow rate. So these are all things within this initial grant that we're working on. So we're going to be measuring those volumes. We have an easy ability in the lab to measure the volumes, but we're working on measuring the volumes up in the field on a limited budget. So this is all also done on a pretty small limited budget.
Yeah, the basic measure here is just, you know, how much water goes through over what period of time, what volume will a certain volume of culture clean up. The time, you know, flow rates through it aren't as important as just how much will be absorbed per unit of culture of corn cobs and fungus.
And once that absorbs the fungus that's absorbed, what do you do with the backwash?
No, actually, that's what Egan was saying. What we do with it on a large scale is
just take it out of the column and burn it. Yeah, I
With
mean,
low heat, so
Yes.
you just ash it and you don't vaporize the metals.
and the one reason why we work with corn cobs, and there may be other materials, we worked with corn cobs in some previous tests, so we knew with going into this that they probably work well. But there's other sorts of materials that may work just as well, that, you know, other kinds of agricultural waste that are closer to Montana. But as Egan said, you can buy corn cobs by the rail car load cheap. So it gives us something to work with. And so it just makes more sense to burn it than to spend the money to try to back flush it and create more wastewater.
And a lot of those systems we're talking about, deabsorbing it or backwashing it are polymer-based beads or other sort of things where the packed bead column is, so it gives a lot of surface area and a lot of space for the fungus to grow. It fills up every little nook and cranny that's in there. And then also the corn cobs have they have a lot of porosity too, so they grow through that. And you're not trying to expend a lot of money on buying polymer beads that you then wash off or then have to figure out a way to recycle, because there's another large cost in figuring out how to recycle something like that and reuse it again or pack it in. And if we scale this up, it's not going to be columns, it's not going to be from the bottom. It'll still be beneficial to kind of be from bottom up, but more often like trenches where the liquid will go in the bottom and have to filter through the whole entire thing before it goes out the top of the next one. And then a series of trenches or lined ponds or pits filled with this corn cob rhizopus culture is what we're thinking once we scale up. So. And as far as I know, on scalability, there's been no scientific literature of anybody doing even the scale that I've done in the lab is bigger than anybody has done ever with trying to clean up metals with rhizopus culture. So the other pipes that are 6 inches round and this tall is taking it an extra step. So we're just trying to step it up each way and deal with the problems as they come. So this is a whole new experimental try. I mean, I've never tried anything like this. I've cleaned up toxic waste using other fungal cultures and oil or trinitrotoluene and other explosives in soil and things like that. We've used different fungal cultures and different schemes to clean them up. So.
How much water?
Of the adit? I think it's 100. Yeah.
150 gallons per minute. What does that equate to? Steady rate.
Yeah. So this is why that's the bigger issue we'd have with this system and the adit is the volume of water. So.
You know, that stuff just shows up as rest.
Yeah.
That looks like you have some kind of overflow.
Yeah, actually, for some reason this year, those settling ponds are functioning really well. Whereas my recollection is, in previous years, a lot of water is actually converting around those settling ponds. It's still converting around those settling ponds right directly into the creek. So, some of this year was really full. They're settling out.
When we went up there with Pedro, it's all over the place. Around the settling ponds is just a marsh.
Yeah.
It's kind of missing some of those. But one of those settling ponds is full of copper. I mean, it's got a blue tinge to it. I mean, so I mean, I think they've kind of maxed out what the settling ponds can do. They're pretty shallow.
And yeah, all that water is eventually going to seeping.
So what is the base level?
Yeah, actually, Jim Olson and I went up there last year and shot the reach below the mill and basically the whole proper reach. So it was healthy west low cut east below. And then, but yeah, it was just like at the culvert crossing, the first culvert crossing. There's pretty healthy fishery there. And right in the middle, downstream of the mill. well, quite a bit downstream, yep. And basically, from the, just a little bit downstream from the mill and up to the attic, we shot. Yes, we talked about it. And there's a lot of, west slope kind of about too.
So, some people are creating, chemical barrier.
Yeah, and that's something that, yeah, and that's what Jim Wilson actually said, that, you know, it's actually creating a chemical barrier. And it could be a good fisheries project. However, he did mention that the west slope cutthroat trout that are upstream of the mill or the whole attic, there's a lot of them, but he said that they're about 95% pure. Not 100% pure. West slope cutters. Yeah, right. Yeah, yeah. So that's something that kind of in the background that we're kind of keeping in the back of our heads is that it could be a good, you know, eventually a good fisheries project.
And there's a bunch of grayling in Elkhorn Lake. I hiked there a couple of years ago before I was doing any of this, and there's a nice population of grayling at the lake. Everything. So there's some good fisheries up there. At Elkhorn Lake. Yeah.
Yeah, and the stream channel that was reconstructed in 2000, it's really silted in for multiple different reasons. There's a drainage ditch that's actually historically significant because that's how the miners actually push the creek out that way and diverted the water around their mill site. And so that's actually capturing water right now, and it's not allowing that new stream to like flush out those sediments. So long story short, the reach below, there's really no fish in the speak of. It's also could be a habitat issue as well.
There's water seeping around.
Tons of water on the landscape out there.
So, assuming that successfully if the work in the field that small quantities, you know, obviously it's a scalability.
Yeah.
If you can develop this and apply it to other sites across Montana, United States, whatever, is there any plans? I mean, I know it's really more of a self-sustainable. So you know, I'm thinking about these pipes that are where people are coming out and using the resource.
Yeah.
But is there plans, big bids and stuff that?
Well, to get away from the PVC pipes and doing a large scale trenches and other things, but these sites that are seeping water forever, I mean, the adits is going to have water coming out of it. There's no way you're going to turn off that spigot. This is going to be water coming out of it for lifetimes. There's no real way to not go out back and clean it up or do whatever else. But we're talking, when I mentioned other mine sites, it could be less hands-on, that you go in once, implement the system, wait in the spring when there's a bigger pulse of metals or more water on the landscape, let that system work and come back and take it away in the fall. And just every year you have a short time on the landscape and collecting and doing other stuff. Cliff and I and actually an engineer that Bob Kearns, who's a cattle rancher in Melrose, and Cliff have worked together for a long time. He and we've kind of designed a shipping container that we could work in a whole bunch of levels of nets that we could blow into the rhizopus at the beginning instead of a column, and climate control conditions in the shipping container, and then you just belt it out. And so we would love to make a plant where we would just have mobile containers worth of a ton of biomass going out at a time to a site. And then if you need to come back and collect it or do whatnot, I mean, there's a lot of issues on scaling and things like that on this, but the ability to be able to demonstrate this was available for the Elkhorn mill and site, and there was these small grants that we could get through the county, so.
Well, and that you asked, I mean, this is, one vision of this is a long-term business where but you have to have, lots of companies get paid to remediate sites contamination, but they do it using best available technology. That's what we have to become, is an available technology. And then there's a business in this. I mean, a lot of these mine sites around, there is no practical way in engineering terms to deal with it. Biology becomes the only real alternative to dealing with a lot of these sites. So we think there's a business there. We're not sure how to get there, but yeah.
Sure. Any other questions?
I just want to make an observation.
Yeah.
Using some resource solve problems. Also, works in biocontrol, please. Have a lot of these years. Towns, it's an area where they introduce some house and that's everything else we the rest of the next year. Next year, there's a few plants where they were coming from. Something.
Yeah.
So I think you need to look at solutions like that. Rather than, it's been given dollars to do our concentration on reasonable.
What?
So fungi.
The most eating argument of the universe.
Yeah. I mean, this is what we do. We're fungal biologists who recognize that Mother Nature has figured this stuff out a long time ago. And it's a matter of utilizing it and building a scale. We're really good at creating a whole bunch of spores in our lab at mycelium. So Cliff has worked on insect control and using fungal pathogens for 30 years. And he developed a Bavaria bassiana that's used now in tons of different agricultural aspects. And then we've also used that same fungus on trying to control in forestry, bark beetles or Balsamolia delgate or other sort of things. We kind of got late to that show and they ate all the trees and kind of ate themselves out of house and home. And so they stopped spreading so much, but we've been working on high alpine spruce and western white pine with the Forest Service in Washington. And there's some seed orchards where they western white pine, they bred for and planted for blister rust, and they're all dying from this teeny little bug called delgate. So I'm there in this June and working on another test with them, spraying fungus around their seed orchard. We have a fungus that was discovered in Yellowstone that has a viral infection and infers drought tolerance. Instead of like a dual symbiosis, it's 3. So it's a virus and a fungus that's in the plant. And so it was found in Panna grass growing next to hot springs that are, the ground is too hot to touch, 90 to 100 degrees Fahrenheit. You pull your hand away and the grass can survive and live. Well, it turns out it infers heat and drought tolerance in grasses. So we're working on commercializing this product for dry land, non-irrigated wheat and barley. And so we can help solve some food shortages that are going to happen with climate change and things. And these, the wheat plants have shown that 7 to 10 days longer than the regular controls and wheat plants without rain, and can survive and come back from their wilt period. And then I've been working on cleaning up different aspects of toxic waste, like I talked about. We're in some conversations with Water Ecology Technology in Butte, trying to think about cleaning up some oil wellheads in eastern Montana over by Williston, and just the oil boom there where they take the oil out and leave a mess. And just on the landscape for a really long time, oil oozing out or just left in their tanks or left on the pad, and we want to use. And what's funny is some of the fungus that we find delicious and delectable, the oyster mushroom, is one of the best ones for cleaning up oil. It eats it really well, breaks it down, because oil's structure is a hydrocarbon, and on a ring, and trees are made out of ring structures, and oyster mushrooms are Mother Nature has taught it to break down wood. And if you break down trees, you can break down a lot of other things in nature. So this is why we do what we do. We take nature and try to apply it to the industrial messes human makes. Well, thanks, everybody.
Hopefully that all made sense.
Oh, turn that off.
Oh, our next meeting is September 23rd.
Okay, so our next meeting will be September 21st, and we'll be talking about sage grouse and wildlife with FWB. And it's at 7. Thanks, everyone on Zoom. Bye.